Welcome to another video in the Unity game series. If you want to learn about object communication, then stick around. When we create a game, there are many entities to think about. First of all, we have the game objects. They can be things like players and enemies and coins and bullets. And a game can typically have many objects like this. We also have game logic that can consist of rules for playing the game. This can include whose turn it is, how much damage an enemy takes when you hit it, or how many points you should be awarded for completing a task. And then we have the game state, which includes data, and this could be how much time is left, what the score is, how much health each player has, an enemy has, what level we're on, etc. And then we have a user interface, which can have menus and text and buttons, and that can show you visual things like what the score is. So all of these objects need to communicate, but we want to isolate and decouple these pieces. For example, we don't want bullets to calculate damage. We don't want the user interface to try to check the rules of the game. Additionally, we don't want to put logic inside an object that is not going to persist the entire game. Whenever we kill an enemy, those enemy objects might be destroyed. And it makes sense to write code to manage each of these pieces. Let's start with the game logic. Here we're not going to have anything visual on the screen. So there's no reason for the game logic to worry about things like colors and animations. Next, we have the game state. This is simply data. It's any data required to play your game, such as the score, health, what level you're on, etc. And there's no reason for the game state to have to respond to lifecycle events, such as start and update. There's very little functionality inside the game state code. Sometimes we refer to these as model classes. And for the most part, it just has data fields with getter and setter functions. And finally, we have the user interface. And this is going to show things on the screen about the game in the form of menus, text, buttons, etc. So we can look at the score and how much health we have. And we want to keep the code inside the user interface focused on user interface code. We do not want it to have to do calculations or game logic. All we want it to do is simply display data to the screen. And the user interface code will need to have the life cycle, such as start and update, so that it can periodically update the data on the screen. To start, we need to make a simple game. We'll make a game that shows squares on the screen and the user has to click them before they move. We covered click events in the last video. To get started, we want to add a raycaster to the main camera. We want to add an event system to the hierarchy. And we'll add a square. And in the square, we want to make sure that we have a collider. We'll go ahead and add a script. I'll call it square script. Go ahead and open up the script. And we want to add event systems. Add the pointer down handler. Go ahead and stub out the interface. Let's add a log message just to make sure it works. And we can see here that the pointer down event is working. You can see the log messages increment as I click them. At this point in time, we want to add some logic to see if the user clicks the square. And if they successfully click it, we want to add to their score. We'll make a script called gameState. We'll open that up. Instead of inheriting from mono behavior, we're going to make it scriptable instead. We'll just have a ScriptableObject. Now we no longer have the Unity lifecycle in this script because this is a model class and its purpose is to store data. Since we don't inherit from mono behavior, the lifecycle events are not available in this script. We'll make an integer called store, and that will store how many times the user clicked the object. We'll also make a variable called time remaining, which will end the game whenever the timer expires. Now we need to make an instance of this object. So we want to add an asset down here that is of the type gameState. The way we do that, typically we can add assets up here, but you can see that this asset gameState doesn't exist. So we can decorate this class right here by adding create asset menu. You can see that there's a couple parameters right here. The first one is file name, and this is what the name of the asset will be called. So we can just call this gameState, and it will make a file called gamestate.asset. The next thing is the menu name, and you can list a hierarchy that you want in the menu itself. And we'll save this script. We'll head back over to Unity. Now under assets, we see something called state and my game state. And we can now create an instance of our game state. So right here we see a new file called gameState, and the extension will be gamestate.asset. So if we look at the files, we can see there's a file called gamestate.asset that was created. Now these two scripts need to know about each other. The square script needs to communicate with the gameState object. So what we want to do is make an instance right here. So we can make it public or we can make it private and serialize the field. And to ensure that the game state is instantiated within this script, we want to make sure that we have a game state chosen down here. So we currently have nothing, and we can look and we can pick one right here. We can either have it none or null, or we can pick a game state asset that we created. The other option is simply to just drag the asset right into here like that. Now, assuming that there's no extensive logic to do, we could go ahead and we could have the square script write directly to the game state script without having to do any game logic rules. We're going to add game logic by creating an empty object, and we can rename it to game logic. And we'll add a script to this. And this time our object is added to the hierarchy, and it's going to inherit mono behavior because we want to be able to use the life cycle. This class also needs to communicate with the data. So to do that, we'll add a reference to the game state. So here's our game logic script. And here's our game logic object. And we can see right now that the game state is empty. So we want to make sure that we click and drag our game state object that we created into here, or just click the dot and select the game state. One of the things we want to do is implement rules. One of the rules is that the timer starts at 20 seconds at the beginning of a game. So we'll say game state dot time remaining equals 20. And we'll also reset the score at the beginning of the game. Another thing we want to do is decrement the timer. So there's a few ways to do this. We can either use the clock or we can just use the delta time. And since this is called every frame, we can simply subtract the time since the last frame. Just like that. So this is inheriting from mono behavior and is called every frame, and the lifecycle events are fired in here. So every so often, this update will be called and it will decrement the time remaining. And every so often, whenever the user clicks on a square, it will increment the score. Now, right now I have this directly accessing the game state. It's probably better to go through the logic instead in case there's any rules, but we'll cover more on that later. So it's best practice to use getters and setters rather than making public variables. However, if we do that, we can't debug quite as easily because we don't see these objects shown in the inspector. So temporarily for debugging, if you want, you can just leave them as true public variables without get and set functions implemented behind the scenes. That way we'll be able to view the score and time remaining in the inspector. So now we can run this and we can see the clock counting down. And when I go over and click on a square, we see it incremented. And I can just click this several times and see that that is working fine. We might want to make the game a little more fun and have multiple squares and have them move around. So it would make sense to make a prefab. So I can just drag the square down here and make a prefab. So we'll make 3 of these. We'll select the prefab and maybe change the color to something else. And then we also have to have these not on top of each other. So I'll just put one there and I'll put one over here. All right, and what we're going to do is periodically move these squares around so that they are harder to click. So we'll add a variable called last update, and that's going to be the time since this update was called. And what we want to do is move the squares around every 2 seconds. So we can initialize it in the start function. We'll increment it by the delta time. And if we have 2 seconds expired, we'll go ahead and move it. And we'll just make a function called move elsewhere. So we need to implement this function. So we want a random spot, but the random spot needs to be somewhere in our viewable area. Right, so to deal with the viewable area, we need to figure out what the camera offset is. We'll make a variable called camera offset. Inside start, we'll figure out what the offset is. And like before, we'll just pass in a vector 0, 0, 0. We'll put the x and y to be 0. And we'll just cancel out the z. Down here in move elsewhere, we need to find a random spot within our screen view here. Inside move elsewhere, we'll get the camera. We'll set it equal to a random value within the range of our camera. So we have the camera width here and the camera height here for our X and Y. And now we convert into the world position from the screen position we just found. And then we add the offset so that our objects don't go behind our camera. Once we have that, we take the square that we're on and we move it to a different position. We run it And it looks like we are running way too fast. And our problem is that we never cleared out this last update after we move. We'll try it again, and that looks better. So I can clear out this console, and I can try to click these things. Pretty easy to do. Whenever we do click, instead of allowing the user to click it multiple times, I will also move it right after we increment their score so they can't keep clicking on it. Do something like that. So now as soon as I click it, the square should move somewhere else, preventing me from clicking it numerous times in the same spot. So you notice as soon as I click it, it moves. And we'll go back to the game logic here. We don't want to let the clock go below 0. So we'll just put it exactly to 0 in case it goes a few milliseconds below. And we can just stop the game like this. So we can see it counting down. I'll click on a couple of these. We see our score incrementing. And the game stops. My time remaining is 0. Now let's work on showing the score and the time remaining. The first thing we'll do, we'll add something called a canvas. That's under UI and then canvas. And a canvas is a container that holds UI elements. So all of our UI elements need to go inside a canvas. And we can go ahead and add a script to this. We can call it canvas script, or we can call it score, something meaningful. I'll call it UI script. And it's attached right here. And what we want to do is add some user interface elements to this canvas. So you'd want to right click on the canvas and add some UI elements. So we will add 2 text boxes. And you'll see them right here as Text Mesh Pro. The first time you run this, you're going to see a pop-up that tells you that you need to import the resources for Text Mesh Pro. So go ahead and do that. You don't need to do this bottom one. It'll just take up extra space. I'm going to rename this top one Game Time Text. And that'll have our time remaining. We'll add another one. So right click Canvas, add the UI element of Text Mesh. And this will be our game score text. And you can see the elements added over here. We'll move the game time up. So you can click this anchor up here and click the top middle, and that will anchor it to the top middle of the screen. And then over here, you can put your offset. Maybe we want it 20 spots below the top, or maybe 40 spots below the top, something like that. The next one, the game score, we'll put that over on the right side, and we can anchor this to the top right corner like such. And then we can push this thing down to be equal Y position, which is -40. And then we can move it over a little bit, maybe over here. You can also center these like this, however you want to do this. And what I'm going to do, I'm just going to put a number in here so it looks more like what our score would look like, and that'll give us a feel. Okay, so our score might be 10, or we might put something like this, :10. And then our other one, our time remaining, something like that. So we're going to leave it on the responsibility of this UI element to go and pull the values for the score from the game state. We are not going to make the game state push values to the UI. We're not going to make the game logic push values to the UI. Instead, we can have a script here that just simply monitors the data inside the game state. So once again, we want a game state object in here. So we want to either make this public or we want to serialize it. So down here in the game state, we want to make sure that this is not null. So we want to go ahead and choose our game state that we've been using. And now we can reference this game state. We need to add a using up here and include TM Pro. And this is actually Text Mesh Pro GUI, like that. And now what we want to do is make sure that the game time text is not null. Same thing with the score. So go ahead and select these. We can either select using the dot over here. And this one, the top one is game time. Or, of course, we can just drag them into here like this. And now we have the game text, time, and score bound to our objects over there. So what we would want to do is periodically update those. In the update call, we can do something like this. We can say that the score text dot text field is equal to the game state dot score, and we do need to convert this to a string. And then the next thing would be the time remaining, and we can convert that as well to a string. And we can see what this looks like. All right, so it seems to be functional, except it's not very useful because of the accuracy of the time over there. So we need to truncate that to whole numbers or something more readable. So we can use a time span and just get the seconds from there. And we'll have to go ahead and add that to the usings up here. That's in system. So we can get whatever we want. We can get the seconds, the milliseconds, whatever. If you want to get, if you want to show milliseconds, you can. I'm just going to go ahead and show seconds up here. And we'll pass in the value like that. And instead of showing the raw time remaining, we'll show this formatted one. And we have formatting that we can put in. We can put hours, minutes, seconds, whatever we want. So I'll show you how to do that. Just put a lowercase m there and a colon. 2-digit seconds will work. And then we'll go ahead and see what that looks like. Now the time looks a little better. The scoring works. And the game just completely stops responding, of course, because we stopped the time. And the time remaining is much more readable. As we have it now, we have the Square editing the score directly from a Square script without making any consideration that there might be rules about scoring. As you can see, when we click on a square, we directly go to the game state and edit the score directly. We might want to go through the game logic instead. So what if we want to count every click for 2 points while there's less than 10 seconds left. We don't want that kind of logic done in a square script. Really, it's not best practice and have our objects write directly to our data. Now in this case, since it's so simple, it could probably work just fine, but it's probably better to let the game logic decide what the scoring is. So we should just simply say that we have clicked a square, and this square script should not know anything about scoring, whether it's worth 1 point or 2 points. So what we're going to do, we're going to change our game script logic a little bit, and we'll let the game logic decide what the scoring should be. All right, so we'll go into the square prefab. We'll edit the script, and we have a variable called gameLogic because we need a hook into this gameLogic object up here. So we're going to find that with a find function. It's called gameObject.find, and we can pass in the name of the object there. And we can assign this to gameLogic. But you can see there is a mismatch type here. This returns a gameObject type, and our logic script is here. Our gameLogic is of type gameLogic script. So what we need to do next is call a get component like we have done, and then just cast it into the type that we want. So in our case, we want it to be a gameLogic script, and then we let that be the function call. Now at this point, we have a gameLogic object in here, and we can now hop up to the on pointer down and call gameLogic dot square click right here. And now we move all of the logic for scoring and rules into the gameLogic rather than letting the square figure out points. So we will no longer even need this game state in here. All we're going to do is talk to the gameLogic instead. And when we look at our square prefab, we see right here that we have this square script. So right now, let's go and play this game. Oh shit, that's not right. Wait, let's clear that out. Why don't you ever work? Okay, and we play it, and we can see that we have 3 null reference exceptions shown. That's because we have 3 different squares that are not correctly finding the gameLogic object. And we notice that our object is called gameLogic right there in the hierarchy. So we'll head back over to here, and the name of the object is just called gameLogic, but the script is called gameLogic script. So we don't have scoring yet, but when I call this object gameLogic and I call the script gameScript, it shows you the difference in these little sections here. So this is the name of the object, and this is the name of the script. They could be the same, they could be different. And that's why I called these 2 different names here, so you understand what part goes where. So let's head back over to our gameLogic script, and we'll do the scoring here. And now we'll do something like this. We'll say if the game state time remaining is greater than or equal to 10, we'll make each click worth 1 point. Otherwise, we'll make them worth 2 points. And we'll head over and try it. So I'll click these one time. We see it go up by 1, go up by 1. Now the timer is below 10, and it increments by 2. And there we have it. We've pushed the logic into the game logic rather than letting the square edit the data directly. And for an added bonus, if you like to play tricks on your friends or students, you could add a cheat code in here. We'll add this code into the game logic script. What we'll do, we'll just examine a secret key like the spacebar. All right, and by default, we will make it, we'll turn the cheat on, and the cheat on means the user cannot score. All right, so the only way to turn the cheat off is to hit the spacebar once. And what we'll do, we just simply will not add to the score. So here we go, running it again. And I am clicking these, and I'm not getting any points because I am cheating. So only I know to click the spacebar once, and now I can score points like this. And there you had it. I hope you found this interesting. If you did, consider leaving a like, subscribe, comment about something you love. Comment about the ongoing drama with Unity and their new licensing scheme. We'll see you next time.